Hello guys, welcome to Tony Panta channel. Today we are going to talk about an interesting topic that is very well known for everybody, the periodic table. As we know, the periodic table, also known as the periodic table of elements, is a tabular display of the chemical elements which are arranged by atomic number, electron configuration, and recurring chemical properties. The structure of the table shows periodic trends. So this periodic table, as we know, is a big chart, and this but now become a very small. We can see it on websites anywhere. So this is a very unique chart for everybody that it's so accurate. It's so accurate. It allows scientists to predict the chemical and physical properties of the elements that hadn't been discovered. Like we are seeing the future of the chemical elements. We predict the elements that hadn't been discovered. The periodic table plays an important role in helping scientists anticipate the types of chemical reactions that could occur and balance equations accordingly. If you are in 10th class chemistry, you would know the balancing of this balancing equations. This is done by analyzing characteristics such as reactivity, pliability, and capacity to conduct electricity and likelihood of combining with non-metals. They combine with non-metals, with reactivity, how much reaction, pliability, and capacity to conduct electricity. So now we're gonna see some facts that are very interesting. As we know, the creator of the modern periodic table is Dmitry Mendeleev, but the first periodic table is created by some French guy. I don't know this guy. I saw him, but he's like a very long name. I cannot remember it, but he's a French scientist who first created the periodic table. Then modern periodic table came, which Dmitry Mendeleev had created. Now, as you can see, this periodic table names is very interesting. They are heavenly bodies, famous scientists, and place it was discovered, property of the element. So let's see some of the mythological concepts. This is so exciting. So the first one, helium. Sorry, the second one, but first in the example, helium. Helium came from the Greek word for Helios, the sun, and uranium, named after the planet Uranus, and plutonium, named after the planet Pluto. Wow, this is going to be interesting. See this, famous scientists. Einsteinium. Guess it. Who is it? Right, it's the Albert scientist, sir. And curium, named after the horn of Mary and Pierre Curie. And Mendeleev. Who? Dmitry Mendeleev himself. He only they named himself in the honor of him. And place it was discovered. Boom. Germanium, Latin word for Germany. Americium, discovered in Chicago, USA. Californium, discovered in California. Oh man, that's so funny. Property of the element, argon, named after the least reactive characteristics, which means in Greek, argon means idle, lazy, and boring. But is because it's the least reactive, they named it as argon. Boring, lazy, idle. And oxygen came from the words oxy and genus, meaning acid forming. I'm breathing acid. Yikes. Okay, the next, a mythological concept or a character. Titanium, named after the Titan, the Greek Superman. And thorium, named after Thor, god of thunder. Now, element 101 is named after the father of the periodic table, Mendeleev, as I said to you. A radioactive element that is made in small amounts. Mendeleev has no specific uses so far outside of scientific research due to its fleeting nature. There are no uses, but they name Mendeleev. Funny. Now we are going to see some advantages and disadvantages in this periodic table. So you think there are disadvantages too? I think you were thinking that, but everything has a disadvantage. So let's see the advantages first, then the disadvantages. So the first advantage is classification of elements based on the atomic number, which is a more fundamental property. We can easily check the name or the without name searching for everyone, because there are so many letters including like helium and hydrogen. Two start with H. Whoa, what's the property number? Here, hydrogen is 1, helium is 2. So that could make the process easier. It explains periodicity of the properties of the elements and relates them to their electronic configurations. So if we, for example, take hydrogen, somewhere in the box or element of the hydrogen, there will be some period that relates for electronic configuration. There's nothing there, sorry, but it relates to the electronic configurations. The reason for placing isotopes at one place is justified as the classification of basis of an atomic number. This is something that's very hard to understand, penetrate into it. So let's jump to next one. The position of the elements that were misfits on the basis of mass number, anomalous pairs like argon and potassium, could be justified on the atomic number. See, atomic number simplifies things. And lanthanides and actinides are placed separately at the bottom of the periodic table. The table is simple, systematic, and easy for remembering the properties of various elements, as it is based on the electronic configuration. So this is mainly related to the electronic configuration of the element. Now let's get into the disadvantages. So the disadvantages are as follows. We could not place the hydrogen element in the appropriate in the periodic tabular form. So we cannot place the hydrogen in an specific appropriate form. And Sir Raymond, that guy said we cannot. She starts with the Freeman, I think. So yeah, he said more than 135 the periodic table cannot withstand. There are some disadvantages. You can stick it down in Google, but there is that disadvantage. And now the third disadvantage is there was no regular trend in increasing atomic mass when moved around the elements. There was no regular trend, like descending trend or ascending trend. First ascending, then descending, then ascending and descending, or descending, ascending. It's so, very bad, not bad, but unordered. It's very unordered atomic mass. So mass comes high first, then goes down, then again comes middle, and then middle low here. That confuses. More elements was yet to be known. There are no Dimitri did not add more elements, was yet to know, but he said these are all the elements. But if we found new things, how? That's what that Freeman guy told. Freeman. And isotopes were found later which failed to comply with the periodic table. See? So isotopes were found later after he created the periodic table and don't know where to put the isotopes, and that made a big disadvantage. And now, as you can see, we are in the end of the topic. You can share, like, and subscribe to my channel in the description box. Near the description box, click the subscription button. And if you don't want to take a chart or do chart and print it, and you don't want to, well, Google and some other website helps it. I'll put those two links in the description box. And I have my own website. You can also click that website and check out on me more. So I'll also put that link in the description box. So bye.